Hi, I just wanted to come on here really quickly and explain the conversion of polar coordinates when you're looking for a positive and negative radius. So, to start off, I think it's always important to visualize what you're actually looking for. And so, here, if you have the point 2, negative 2, you're either going to have to find the angle going in the positive direction here or this angle right here. So now that we have our point, it's pretty straightforward from here. You just plug in your points into this equation or this formula right here. If it looks familiar, that's because this is the equation of a circle. And so if we do that, if we plug our numbers in, we get that the radius is equal to the square root of 8. To find the angle, you also plug in your numbers into these equations right here, and you get arctan negative 1 is equal to theta. Now, usually you can get negative 1 through 3 pi over 4 or 7 pi over 4, but you have to keep in mind the range of arctan. The range of arctan is pi over 2 to negative pi over 2, meaning that any values that you have in quadrant 2 or quadrant 3 are out of the range of arctan, so you can't use them. This means that we only have 7 pi over 4 left. So this is our answer, and in this situation we have no quadrant correction. A quadrant correction happens when you have a specific angle that you're trying to find that is outside of the range of arctan. And I think this will become a little bit clearer once we see the other examples. So here we have the same exact point, except now we're looking for the negative radius. And what's important when you're looking for the negative radius is to extend that line going through the original point that you had. And once you do that, once you've extended the line, you're going to be able to find the new theta, the new angle that you're looking for. So to find the radius now, it's the same process except that you multiply the radius by negative 1 so that it becomes negative, right? And for the angle, you get to the same step. You get to arctan negative 1 is equal to theta. Now, once again, you have these 2 points as options. And because of the range of arctan, usually we say, oh, well, the answer is 7 pi over 4. But because this is not representative of the angle that we're trying to find, we do need a quadrant correction. And in this case, a quadrant correction would be 7 pi over 4 minus pi. So that once you do minus pi, you get into a completely different quadrant, which matches the quadrant of the angle that you're looking for. Right here, we're in quadrant 2, but if we use 7 pi over 4, we're in quadrant 4. So what do we need? A quadrant correction, which in this case, once again, it's putting a negative pi. So this is our final answer. Now, let's try another example. We have negative 1 and square root 3. So if we plug our numbers into the equation of a radius, we get that r is equal to 2. Same thing, you plug in your numbers and you get arctan negative square root of 3 is equal to theta. Once again, we have two options. We have 2 pi over 3 or 5 pi over 3. Now, keep in mind the range of the range of arctan, which is pi over 2 to negative pi over 2. So we're left with 5 pi over 3 being the answer. So here we have a quadrant correction, right? Because what's representative of this angle right here would be an angle in quadrant 2, which would be 2 pi over 3. Except since this is not part of the range of arctan, in this case we would need to add pi so that it's 5 pi over 3, which is in the range of arctan. This seems a little bit complicated, but just remember that the angle that you're looking for has to match the quadrant that you're in and the range of arctan. So here, this is the angle that we're looking at, it's in quadrant 2. So usually your answer would be 2 pi over 3. However, because of the range of arctan, your final answer is 5 pi over 3. So try not to confuse yourself too much with that. To find the coordinates for a negative radius, like we did previously, we're going to elongate that line that passes through our point to find our new angle right here. So we have that r is equal to negative 2, and arctan negative square root of 3 is equal to pi. Once again, we have these two angles as our options. But now, since we're looking at this angle right here, it is representative of 5 pi over 3, which is also in the range of arctan, which makes sense. So we don't need a quadrant correction. We don't need to get here to 2 pi over 3, um, because this is already in the range of arctan and it is representative of the quadrant that we're looking for. So I just wanted to show you these two examples to let you know that just because you have a negative radius doesn't automatically mean that you're going to have a quadrant correction. So just keep in mind that if you're in quadrant 2 or 3, there is going to be a quadrant correction, but if you're in quadrant 1 or 4, there is no quadrant correction. So the value that you get for arctan remains the same. You don't need to add pi or subtract pi. So hopefully that was useful. If you have any questions, I'd be really happy to answer those. See you.